Welcome to our presentation. We're going to be talking about the key components to a profitable and efficient grow, presented by TSRgrow and JPT Architects. TSRgrow is a horticulture lighting and solution company that has been working with companies across North America and developing next level solutions for the cannabis, medical, and horticulture market. JPT Architects has over 20 years of experience in alternative healthcare and horticulture, and is at the leading edge of designing cannabis and other horticulture growing facilities. I'm Mikhail Segal, president and co-founder of TSRgrow. Gary Arnold is VP in Sales and Marketing, co-founder of TSRgrow. And with us today is Brent Spangler, Senior Electrical Engineering Project Manager with JPT Architects. We're going to be sharing the essential components that go into a system that are going to develop a profitable and successful grow. Two main elements that go into this is the design and the building information and integrated systems. And through this presentation, you're going to have, hopefully by the end, a clear picture of what's needed to achieve success in commercial horticulture solutions. With that, I'm going to turn it over to Gary Arnold, and he's going to continue from here.
Thank you, Mikhail. Hello, everyone. Thank you very much for spending the time with us today. We want to go over some of the more critical areas that you should be looking at in any successful design. And we're going to start off with the facility design. Obviously, it's more than an envelope. It's what goes inside that is as important as the outside, but it has to go together. So we've got to look at the complete architecture, and we'll go through some of that later into the presentation. Lighting as a platform, obviously, this is a great opportunity for people to take advantage of the installation and wiring that you've done for lighting, because lighting is in every room. And basically what we do is we remove the actual power drivers, the electronic drivers off the fixtures themselves, put them in a computer-driven control rack outside of the grow area. And in that rack, we're able to run all of the communications and integration for all of the data in your facility through that one hub. So it gives you a real unique opportunity to bring all the information into a common source and be able to handle it properly. Production costs, obviously, there's a lot of things that go into that, but electricity is really the single largest cost. And the way to really get your arms around that is to know what you're using at what time, and also be able to limit your power consumption. For example, when you get up to demand peak charges or something of that nature, well, we can manage that for you in a lot of the integrated solutions we have. But it's obviously a big one you have to look at. Integration of systems, it basically is, many times we see individual systems going in like silos. So it might be CO2, might be fertigation, irrigation, lighting, and the HVAC. They're all kind of separated systems. And basically, when you look at it is, again, it's an opportunity to integrate that together. And we'll go into some of the advantages and details of that later on. But ultimately, it's coming down to having the highest quality production, and obviously not having mold at the same time. So the control of that's very important. DC power and utilities, we see a lot of facilities that basically are power strapped, and they're looking for ways to augment the power. And solar, battery, mini grids, even cogeneration are all systems that go into that. But DC power is really what we're talking about. So if you've got solar and battery, you're generating DC power right there. And it would be good if you take that DC power and bring it right into your lighting system. And that's something that we can bring into our system and provide that communication platform on the power side too. Environmental monitoring is, covers a lot of things, but what we see in growing right now is we see too few monitoring systems put to use right now. One of the biggest areas and challenges we see are microclimates, and microclimates, especially in vertical growing. And so you've got to look at your temperature, humidity, your BPD, your CO2, and even your air movement as at different levels and stratosphere of your vertical grow, because they are different at each level. And so if you monitor those properly, and again, bring those into your central communication platform, then you can actually set up each level, each zone, so that you can get the proper control and basically have consistent quality product. If we take a look at equipment diagnostics, it's nothing worse than to, find out that a pump or a motor stopped, a couple hours ago or maybe yesterday. And there's no reason why that should go unattended and unknown. And again, this is part of our communication strategy, and the platform we put in is to be able to monitor all of these different points that are critical to our growing operation. And if there is a problem, we'd like to try to see it before it ends up being a failure. So if we can kind of predict something's going to fail by certain measurements, then we can forewarn an operator or a maintenance person to take action and correct it before it ends up being a problem. And then looking at the balance of plant is basically tying together all of the different subsystems, and whether it be the HVAC or the feed system, irrigation, it's really tying all of those systems together so that you're going to get a unified set of data that you can make decisions on going forward. Next slide, please.
So right off the bat, communicating your needs is the most important thing that you want to look at. There's 6 questions that should be asked. Obviously, finances are going to be part of your project, but not only construction operating cost, but you may see fees coming in from utilities. They may have to do research on their capacities, and finances available through grants and rebates can be available. You might be able to set something up with vendors for vendor financing. So that's a critical portion of the project. The type of facilities that you want to build is also plays into this. Is it going to be an indoor grow? Are you looking at a greenhouse? Are you going to do tables, vertical grow, local nutrient injection, or are you going to do a centralized system? You need to know a lot of this stuff, or at least have input on a lot of this stuff right up front. Your cultivation approach, which plays right into the type of facility that you need. But here we're talking about things like your temperature in the facilities. What range are we looking at? Are we looking at humidity levels? How long what's your watering rates? How long are you going to leave plants in veg and flower? And available utilities. A lot of times the site's selected based on cost, and no one looks at what the utility sources are. You may have a substation that's 6 miles up the road for electrical, and you might have to build that distribution up just to get power to your facility. Natural gas, is it available, or will you have to bring in or set up a propane farm tank? And what's your production goals? What's the local market look like? There are flowers. What's the flower or extracts? They're looking for extracts or edibles. What are you going to do? Because this then plays into, are you going to have a kitchen? Are you going to be doing everything on site? And the timeline, always with permits, there's a timeline that's involved, and from the issuance of the permit to the beginning of your process. And we would have to look at things like, we may still be under construction in part of your facility, while the other parts were running. So we would have security issues and site access issues. Next slide. So it's a collaborative effort. You know, everybody needs to be involved as soon as possible. You want to get your team members in there. You know, everyone comes to a project with preconceived ideas of what they think a cultivation facility is. We need to get their ideas on the table. Everybody works together and have a buy-in to a collective idea of how your facility is going to be operated and constructed. You need a master grower there. We need to talk to them about watering rates, what your plant density. We want to know what they're thinking about as far as, you know, is it going to be a sea of green, you know, in there. Your product processors, you may have individuals that'll be allocated to take care of the dry cure, the trim, the extraction, or the kitchen for edibles. We need them to talk to them of what they're thinking and how they do this. Vendors are critical to get into the picture as soon as possible. They know their systems the best and how they integrate with it. And we need to talk to them and see what they're doing. If, you know, we can work with you on things before, but, you know, the earlier you get them involved, the better. You're going to need your architect and engineer on board. The architect helps you with the layout and can tell you the codes that you need to comply with in your facility, and the engineer applies the physics behind everything and makes sure everything can talk together. Our facilities are constructed a little different than a normal building. So bringing a contractor in early is always beneficial. So they understand how things need to go together to make this a successful project. And finally, you need somebody, an accountant or somebody that looks at the money side of things and keeps everybody in control, and so that you're not overspending from day one. Next. So an integrated design is really important. Not a silo approach. You don't want to go out and pick parts and pieces and in the end find out they don't communicate. So you start out with your facility design. Everything feeds into it. You pick your system hardware in a way that you know that it can communicate and work together. It integrates. You coordinate construction along the way to make sure all the processes work and everything can be built on your system. And you don't leave out the system commissioning. At the end, you need to make sure everything was put in the way it was designed and it's operating. And then that leads to a successful cultivation. Next.
Okay, so elements of success, obviously we want to look at two major areas: centralization of all systems. As you can see in the diagram there, we're really tying together a number of the subsystems, and an integration of all facility design elements. So that's really, that's really what you have to start with at the beginning if you're going to come up successful. Next slide. Centralized lighting is really an opportunity that we bring to the table in a couple of ways. Number one, we remove the ballast or the electronic drivers off the light fixtures themselves. So picture that as all of your fixtures now are a light bar, and the electronics that drive, or the power that drives those lights, are now in a computer-driven rack that we basically integrate in another room outside of the grow area. And basically we can do a couple of things. First of all, it's moving heat out of the grow area. It reduces your HVAC and your operating cooling costs as you're going forward. It also puts the electronics in a convenient, accessible area where you can get to it. But more importantly, the data that's in that computer-driven power system gives you all of the power consumption, gives you the data mapping of each zone of your operation, and you can see diagnostics, you can see other activities that are going on through that. And then we can tie in other attributes of sensors and other monitors in the same system. Next slide. If we look at communication of all of the systems, whether it be, cogen from, irrigation to fertigation to lighting to HVAC, all of those systems are independent and they need to be tied together. And you look at right in the middle is our data hub, which is our remote power server for our lighting. Because that's computer driven, we can actually bring all of the data in from these other operations. So we can manage the, we can manage the operation, we can record the activities, we can have warnings and things that will be preventive in terms of any downtime to give you, full control of the operation. Next slide. So if we're really going to use the information we collected together, it really is what we call a master recipe. And this is where we'll call it the rubber meets the road. This is where you tie all of the variables together so that when you have a change in your temperature because of maybe a pump went on, a bank of filters might have kicked in or something that was unscheduled that's going to interrupt or something like that. You want to be able to measure that and you want to do something about it. If you can't control the HVAC, then maybe you should be controlling the lighting to drop that down. If that goes a period of time, maybe you should be adjusting your watering at the same time. So what that really means, we have to tie it all together. So we need to know what each one of the variables are doing, what they should be doing together, and where that ties into the schedules that you're growing right now. What week are you in? What stage of your growing you're in? And what are the different set points that you're putting in every day to make those adjustments for the plants to get the greatest yield out of them. And then the other part of that is to be able to track all the information that is going on, both real-time information and measurement, and as well as individual interaction. So if you get people setting set points and making changes, you want to capture that. And the reason you want that is that once you've gone through a successful grow, you want to know what you did to make that happen, because you might have done some adjustments that ended up being very key to that result. And wouldn't that be good to know when you're going to set up the next cycle? And then you can look at the historical records of looking at what did we do with certain strains and how did we get those to perform as well as they did versus what we might be doing today, or how do we adjust that to maybe get a little better work up on it. So the master recipe part of it is not just a simple tying things together by communication, but it's really taking data and making that work for you. Next slide.
Let's tell you one more time, don't forget your utilities. Oftentimes the utilities are the afterthought by most of our clients. And where is your electricity? Is it 6 miles up the road? Will they have to rebuild lines? Maybe you will have to have on-site power where we put in a cogen or a solar field for that. The domestic water, is it going to be provided locally? You're going to have wells, or if it's the local municipality providing water, you still need to coordinate with them. They may not have enough. We use a lot of water. Natural gas, is it available, or do we have to have a propane field there? All this needs to be taken into consideration right up front for a successful project. Next. So integrated facility design, we utilize BIM, and BIM's been around since the late 90s. To do this, we use a centralized model, a virtual model in the computer. Everybody has access to it on the technical side of the team, and we can all the team members can populate the system. So right up front, we see coordination issues as the mechanical system comes in or the lighting system comes in. Everything can be worked out. All the coordination can be taken care of right there. Our model, when we actually built the model, it's located geographically on Earth where it's going to be. So we can look at the climate in that area. We can look at solar systems designs. We can do shading studies. Are we going to be putting solar panels on the roof? Everything is right there. We can import and export information from our centralized model to other specialized systems that just take care of this, for things like airflow, equipment auditing. So it's important. So typically we would recommend that your model or this central virtual model will be updated as things change in your facility. So we can easily audit when a piece of equipment went into that facility, what's its life expectancy, how many pieces of equipment of that type are in the facility, what's the manufacturer's recommended maintenance cycle for that. And a very key aspect is the facility visualization. You can walk through the facility virtually and see conflicts. We're going to show you that in a second. But that facility visualization is different today. It used to be just a piece of paper where you would see plans and nobody really understood any conflicts. You can now see all this thing in a virtual environment. And all this goes together to save you time and money in the end. If you can take care of it virtually before it's constructed, you're going to be well ahead of the game as far as economic costs are concerned. So now we're going to walk you through a short clip of one of our designs, so you can see how this all works out.
Typical designs are on paper in 2D. However, JPT actually designs the facility in 3D using BIM, a building information model. This model can quickly be converted into renderings that provide a visual understanding of the spaces within a project design, allowing quick and efficient identification of possible coordination issues. Here we are standing in the corridor of a cultivation greenhouse. You can easily see the space the equipment will occupy, as well as possible conflicts with equipment locations. Within the cultivation space, you can see the coordination between the TSRgrow TG1000 HVR cultivation lighting, HVAC ductwork, horizontal air fans, structural elements, and other system equipment. The model lets the user to accurately simulate typical climate and solar information, allowing detailed energy modeling to be developed. As can be seen, an accurate evaluation of distances between the top of table height and cultivation lighting can be determined quickly. As you're walking, notice the positioning of the light fixtures. They do not obstruct air movement, which is especially important in large cultivation facilities. These fixtures have adjustable intensity so PPFD can be maintained as plants are growing in height. This allows for peak performance and growth. Equipment models developed from manufacturer information allows for accurate space allocations for connections and pathways to minimize coordination issues. Exterior building finishes matching the construction materials can quickly be applied to the structure to allow visualization of the facility. Here we are entering the corridor of an indoor cultivation facility. The user can again see possible obstructions in this area and determine an appropriate plan of action to mitigate issues prior to construction. In this area, space allocations can be seen by the end user and their adequacy can be determined. Existing facilities can be populated with the appropriate equipment, allowing the user to identify possible conflicts between systems and determine the correct course of action required to rectify issues. You can easily see the space, the TSRgrow TG1000 HVR fixtures, and table to determine possible plant growth height. Also, access pathways can be easily seen and evaluated. Cultivation racking systems can be evaluated for coordination with lighting, cable tray pathways, HVAC ductwork, and potential plant heights. Centrally located, the brains of the integrated system sit outside the cultivation facility and support the operation, which includes lighting drivers heat removed from grow area, centralized control and maintenance, monitoring of all assets and environment, reporting, data trending and control from anywhere, alerting and interconnecting to solar, battery storage, microgrids, and power utilities. Utilizing BIM, Building Information Modeling, to develop a project can allow end users to visualize spaces prior to construction and make changes if required. It can visually identify conflicts between systems and reduce coordination issues, and it can save the owner both time and money along the way.
Okay, thinking long term. Basically, it's all about keeping costs down and getting not only a healthy balance sheet, but having a competitive operation. There's one thing that we always stress with people right up front is that look at your costs, look at your operating costs. It's going to be critical, not just to start your project and not just to get going, but it'll make a difference in your competitive situation going forward, because that bottom line cost is always going to be there. And if anything, it might grow because of energy costs tend to creep up a little bit. So you want to have that the lowest as you possibly can, and that's using some pretty solid control systems as far as we look at it. And obviously, data is really where you're going to make a difference in your branding, and your going forward is a competitive advantage. Because once you've done something good, you've done a lot of hard work in getting your strains and getting your varieties and getting your growing techniques, and now you want to be able to maximize that product value and that brand. And you're going to do that through history of what worked for you, what can you perfect, and how did you do that? And then plan for the future. What is the future holding for us? I mean, obviously, there are a lot of known knowns in this industry, and the unknowns start with regulations. We know that those are changing, almost weekly or monthly, and they will change, and they'll change significantly going forward. So, how might that impact your business? What's the competitive landscape, and how are you going to make brand differentiation? Because basically, it really comes down to we're not really manufacturing something that's going to be an average run of the thing. We're talking about a brand. We're talking about taste. We're talking about looks. We're talking about quality. You are anyway, and you want to be able to make that the top thing you bring to the table. But there's a lot of things that are going to affect even the packaging. A lot of things are going to affect how we're going to be looking at business going forward. So think about it. It's really up to you to be successful if you think about the future. Thank you.
So in summary, we've heard today about two key things, the integrated design and the integrated systems, and how bringing those two things together are critical for your success and for a winning strategy for your cultivation and go-to-market strategies. By bringing those things in from the beginning, all of the things can be planned, all the systems can be thought through, everything can be integrated together, visualized, mapped out, planned, and implemented in a manner that's going to bring you out of the gate from the beginning, running at a lowest possible operating costs with the biggest advantages to your competition going forward. You're also thinking about how you can expand in the future. And by having everything integrated together and working together is going to give you speed to market, ability to maintain what you're doing, have SOPs that are critical, giving you quality that's above and beyond, and really the ability to monitor everything that's going on in your facility, tie it all in, integrate with utilities, integrate with your BIM system, and really give you a formula for success. And these two things are what JPT Architects and TSRgrow are excited to be able to bring to you, and we're standing by to talk to you about your facility and your expansions and how you want to go to market and work with us. Thank you very much, and we look forward to working with you in a project in the near future. Have a nice day.